This is the last topic, which is about combining chain and product rules. We didn't do one of these product rule questions, so I'll just go back and quickly do that now. It was the last example, finding derivative of three things multiplied together. It's basically two ways you can go about this. One way is to consider this to be u and this to be v. And when you have u equals x plus 1, you can then go down again and say, well, this is u and this is v, and do a little product rule to find u dash down here, okay, using new u's and new v's. However, for one that's reasonably straightforward, like this example, I would probably just multiply out one of the sets of brackets. So I'll have x squared plus x and 2x plus 3. Okay, and from here I can write it as u times v. Okay, u is x squared plus x, v is 2x plus 3. I can find the two derivatives, pretty straightforward. 2x plus 1 and derivative of 2x plus 3 will just be 2. So my derivative, just make sure I use the same notation all the time, u dash v plus u v dash. I'm just going to slot in all these things that I know. So 2x plus 1 times v, which is 2x plus 3, plus u, which is x squared plus x, and I'm multiplying all of this by 2. Okay, and then if I wanted to, I can expand and collect like terms. Okay, we should be getting pretty good at this expansion by now. And expand the next set of brackets. Okay, look for like terms. I got some x squareds here, 6x squared, and I've got some x's, 6 and 2 is 8 and 2 is 10. And I've got a number coming along as well. Okay, so there's my derivative. Alright, so you can be a little bit creative with these. In the examples we'll see today, you need to combine a few of the laws together, but we'll still just stick to the same strategies. Remembering that when we differentiate things that are added together, we just add, like this says, if y is some function plus another function, we'll just add the derivatives together, okay? Or if they're subtracted, subtract the derivatives from one another. So when I'm differentiating this expression, which is three functions added together, I just differentiate each part by itself. Okay, y dash will be 6x plus 7 and then plus 0. Okay, I don't need to write the plus 0 at the end. So we'll just use the same idea when we involve chain and product rule as well. Since we've done a few chain rules, we probably don't need to be writing out that whole dy dx, dy du, du, dx. Okay, hopefully you've got the idea that when we're differentiating this first term, okay, we're just pretending that this thing is just a block, differentiating it, and then multiplying by the derivative of that thing that I crossed out. So when you're differentiating a few things at once, like this one, I'd probably just do it all in one line. So my derivative, dy dx, is going to be, well, imagine this is just a block. I'll have multiply the powers together. 3 times 3 is 9. X plus 4 to the power 3 minus 1, which is 2. And I'll multiply this by the derivative of what's inside. So the derivative of x plus 4. I'll do the same thing to the next term. Okay, multiply by the power. So 4 times 5. I'll write that neater. Okay, this 2x plus 1, I'm going to reduce the power by 1 and multiply by the derivative of the thing inside. And for the last term, I'm just going to differentiate that like normal. Minus 5x squared differentiates to minus 10x. Okay, from here, need to actually differentiate the things inside the brackets. Alright, so write this as is. The derivative of x plus 4 is 1, so we multiply by 1. So I've done this whole section. I'll move on to this next part. So add, well, this is 20 2x plus 1 to the power 4 times the derivative of this thing, which is 2. Okay, and then my minus 10x comes along as well. I can neaten these up a bit. 9 times 1 is 9. 20 times 2 is 40. And my 10x can come along as well. Okay, I consider that as simplified as it can get. Okay, eventually you'll be comfortable enough to just go from this top line all the way down to here and just multiply by the derivatives as you go. But we're just gradually simplifying the setting out. All right, example 2 is a product rule and a chain rule combined. So I'm going to notice that all of this is u and this part is v. Okay, I need my whole function to be u times v. We can use the dot instead of the time sign. And I'll state what u is. So u is 8 times 3x plus 4 squared. This ampersand here, I assume, was supposed to be a 7. Okay, so v is x plus 7 to the power 4. Okay, I'll find u dash and v dash like normal. So u dash will be 8 times the power, so 8 times 2, and then reduce the power by 1, so to the power 1, times the derivative of 3x plus 4. And we'll do the same thing to v. Okay, so v dash will be the same thing, multiply by the power, so 4 times 1, x plus 7 to the power 4 minus 1 is 3, times the derivative of x plus 7. Should be able to find what u dash is. We've got 16, 3x plus 4, and multiply everything here by 3. So my u dash will be 48, 3x plus 4. We'll just leave it like that. We'll see why in a moment. V dash 4x plus 7 all cubed times derivative of x plus 7, which is just 1. So v dash will be 4x plus 7 all cubed. From here, I can use my product rule. So I've used chain rule twice so far. Now I can actually find the derivative. Make sure I'm using the same notation. As long as we grab both of them, it's okay. I'll slot in all of these u dashes and v's. So u dash was 48, 3x plus 4. V was x plus 7 to the power 4. U is 8, 3x plus 4 squared. And v dash is 4x plus 7 all cubed. Okay, from here the simplification is pretty important. Alright, so I'll look at what like terms I have. So looking at the numbers, I've got 48 here, 8 times 4 is 32. Think about what's the highest common factor between those two. I think it'll be 4. 48 and 32. 4, do we have 8? Okay, 8 will be even better as a common factor. You can write that as 32 before you do this. So 8 is common factor for the numbers. I'll look at the 3x plus 4s. I've got 1 here and a squared there. Okay, so I'm going to take out the common factor of 3x plus 4. And I'll also take out, I'll look at the x plus 7s. I've got cubed and I've got to the power 4. The lowest power is cubed. So I'll have x plus 7 cubed. Okay, as my common factors between those two terms. Not sure what happened there. Alright, so I'm going to go back through these two terms and write what's left over. So from the numbers, 48, 8 times 6 gives me 48, so I'll put a 6 here. 3x plus 4, well that's already taken out. And in the x plus 7s, I need one more x plus 7, okay, to get to the power 4. Do the same thing with the next term. I've taken out 8 already, so I just have the 4 left over. I've taken out 3x plus 4, I had it squared, so I need another 1. And looking at the x plus 7s, well, x plus 7 cubed was my common factor. I've taken out that whole factor. Alright, so I can write all these factors beside themselves, and I can expand this bracket to see if I can simplify it into one expression. So I'll have 6x plus 42 plus 12x plus 16. And hopefully I can just write this as a whole heap of factors. Okay, 6x plus 12x will be 18x, and 14 plus 16 will be 58. That's basically done as it is. If we really want to be fancy, we can look at this last factor and take out a common factor of 2. And be left with 9x plus 29. And multiply these two numbers, 8 times 2, to give me 16. And this is the answer that the text would probably have. Okay, it's all simplified and factorized so that when I'm differentiating, I'm probably trying to find a minimum or a maximum. So I'm likely to then set this equal to 0 and try and find where the slope's 0. Having it simplified like this will allow me to do that a lot quicker. Example 3, okay, is pretty much the same as example 2, but it's using that idea of bringing that negative power up. So I'd rewrite this as 9x plus 3 to the power 6 times 2x plus 1 to the power minus 4. I would say that this is u and this is v, and then I'd go about saying I'm going to use the product rule, u times v, where u equals this big thing, the first half, and v equals 2x plus 1 to the power minus 4. And then you'll have a lot of fun once you differentiate it and put it all together in product rule of trying to find common factors and simplify that fraction. I'll let you guys have a go at that. You can come show it to me at the end, and I'll put a solution of this up on Canvas as well so you can follow the algebra along. Alright, enjoy.